In this lecture, we're going to look at what could happen if you try to manipulate data out of the bounds of your array. We have seen that when you allocate space for an array, the computer is going to give you a bunch of memory locations you can use to store your data. And it's going to be of the size that you have specified or that is deduced by the compiler. So here is an example of an array that is going to store 7 elements. And we have green slots for these elements, and these are the locations we are allowed to manipulate in our C++ program. If we try to go overbound, for example, if we try to modify something before our array or after our array, it might be a memory location that is owned by another program. It might be a memory location that is even being used by the operating system. So bad things can really happen if you try to use data that is outside the bounds of your array. Let's try to look at a simple example here. Here we have an array called numbers. We have 10 slots inside. So we are only allowed to modify the memory locations for these 10 numbers. And if we try to access something outside the bounds of this array, something might happen. But some people say that C++ is really funny because it should be stopping you from doing something like this. But C++ allows you to do this. If you look at code here, we have an array, we have 10 elements in, so the valid indexes we can really use are from 0 to 9. But if we try and access something at index 12, the code is going to compile, and if we run it, we're going to get something printed out. But that's something, this is going to give you garbage data, or you might be even trying to read some restricted memory, and your program is going to terminate immediately, and we're going to say that it has crashed. If you try to write over bounds, the compiler is also going to allow it, but you don't own the memory, so other programs might come and change that memory location, and if you try to read from it again, you're not going to get what you expect. Another thing that could happen is that you try and modify data that is owned by other programs, and you might imagine how bad that really is. So the message here is don't go over your array bounds, and you're going to be playing in the safe zone. Let's head over to Visual Studio Code and play with this a little bit. Here we are in our working directory. The current project is array bounds. We're going to grab the template files and we're going to put them in place. And we're going to open this up in Visual Studio Code. We are going to declare an array and try to read beyond the legal bounds of our array. So let's try and bring up a terminal here, and we are going to build this with GCC. The build is going to go through. You're not going to get a compiler error, but if we run this, we can really get anything. And you see we have a number. We don't really know what it means. And this means that you have read out of the legal bounds of your array. And C++ allows you to do this. And the reason they do this is because they expect you, the developer, to know what you're doing when you try manipulating things like array. And now you know this, and be careful when you are working with arrays like this. So don't go over bounds, that's the message. We may also try to modify data beyond bounds. So let's go down and put in the code to modify things. And I have put a clear message here as a comment to let you know that this is really something you should be very, very careful about. So we're going to try and change that number to 1000, and we're going to try and print it out and see what we get. But this memory location at index 12 is not something we own. So other programs might come and write to this location, and if we try to read from it again, we might not get what we put in here. Even worse, this memory location might be owned by other programs, and if they read, they're going to get what they didn't put in, they're going to get what you put in. And this is something bad. We might try and really go crazy with this. Let's put in a really huge number and see that we can do that. This is a good way to learn, by the way. It's going to compile. And let's try and print what we have in there. And we're going to say this location here. And that's what we're going to say here. And we're going to build. Again, the build is going to go through. You see that we are doing something really crazy. Our array has 10 elements, but we are trying to modify something 1 million memory locations away. And this is really crazy, and C++ allows you to do this. So let's clear and run did we build. Let's make sure we have build. So let's build with GCC and clear and run Rooster. Our program is crashing because we are trying to access something that isn't really ours, and you see it has crashed. Okay, for example, if we have something printed out after this, let's say std program, and then so that you can see it is really crashing, and say std_ndl. This statement here is not going to print because once we hit this location, we're going to try and modify this, and the program is not going to be able to do that. It's going to crash. The operating system is going to notice that we are trying to do something crazy, and it's going to say, this program is really crazy. It doesn't know what it's doing. I am going to kill it, and it is going to stop. That's basically what is happening here. So let's build again with GCC, and we're going to clear. Let's clear and run Rooster. You see that it's going to try and do this. It's going to try and put a value in here. The program is going to end here. And this is really bad because memory locations you have allocated for before here are not properly released and returned to the operating system. And this is something really bad. So the message is, don't go over bounds. Make sure you are working within the legal boundaries of your array. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to see how we can generate random numbers. And that's going to be the foundation for something fun we want to do in the lecture after that. Go ahead and finish up here and meet me there.